Okay, so in this section, we're going to talk about when minimums and maximums of quadratic functions occur and where they're located. So they're really just combining two ideas that we've already had. One is knowing whether or not a quadratic opens right side up or upside down, and whether that creates a minimum or a maximum. And then the second idea is what we had is from general form, how to locate that vertex, so therefore a maximum or a minimum within the function space. So the other thing is that they are doing a breakdown on this in regards to how we saw this when we were talking about getting information from graphs. And we talked about there being a maximum value, where it occurred and what it was, that could be split into two separate sections. So what we have here is if A is greater than 0. So if A is positive, then the vertex, which we had from our general form, is negative b over 2a. F of negative b over 2a is a minimum. And we know that because A is positive, that our quadratic opens right side up. So it's a traditional U shape. So that does create a minimum. Now, the second part of this statement is where they're breaking that thing apart. It occurs at negative b over 2a, which is the x portion of that. And it has the value of the y portion, which is f of negative b over 2a, which is, again, just plugging the stuff in. Now, if A is less than 0, meaning A is negative, we know that the graph or the parabola opens downward, so it's a hilltop. So it does have a maximum at negative b over 2a, f of negative b over 2a. Again, that's just our vertex form that we saw from general. And again, they're going to split this up. It occurs at the x part, which is negative b over 2a. And that maximum value is going to be at f of negative b over 2a. So let's take a look at an example here. So we've got, consider the quadratic function 4x squared minus 16x plus 1,000. And it says determine without graphing, so they don't want us to go through the graphic process with this, whether or not the function has a minimum or a maximum value. Okay, so we're going to look over here onto our lovely whiteboard. So I've got negative 4x squared minus 16x plus 1,000. Okay. And so they want us to decide whether or not this is a minimum or a maximum. So we start by looking at our A value. Since this is positive 4, we know that our graph is going to open right side up. It's going to be a U shape like this. And so we know that we're going to have a minimum. Now, at this point, that would answer everything that they wanted us to know about this one, okay? Because they just asked maximum or minimum. This would have a minimum. Now, if they were to ask where it occurs and things of that nature, so we would do negative b over 2a. So that's negative 16. Make sure you take your signs with you when you go. So that's going to be positive 16 over 8, which is 2. So it occurs at x equals 2. And then if they wanted to know what that minimum value is, we would just plug that into our equation. So again, we're just taking where that minimum is going to occur at, and we're plugging it back into our original equation. So 2 squared is 4. 4 times 4 is 16. 16 times 2 is 32 plus 1,000. So I've got negative 16 plus 1,000. That is 984. So this is that minimum value. And again, the same process would be followed to find where a maximum would occur and what the maximum would be. The only difference would be for that one that this value up here would be negative instead of positive, and that would create a maximum instead